Hi, this video is to show you and talk about an important concept in statistics, which is the empirical rule. The empirical rule is based on the assumption that the data has this bell-shaped normal distribution. Remember, we talked about histograms, and this is a histogram about the height of people. So in this axis, we have different values for people and their heights. And on average, in the center of this distribution, we have the mean or the average. The average is 5.7. And here is the relative frequency, the percentage of people with different heights. So this has a bell-shaped distribution, which is similar to this one. So if the data is distributed like this, we can apply this empirical rule. What the empirical rule says? The empirical rule says that approximately 68% of the data values that we have in the distribution, for example, let's say the height of people, 68% of the height will be within 1 plus and minus 1 standard deviation of the mean. So here is the mean. Let's assume we compute the value of the standard deviation. This is what we learned in previous videos. So one standard deviation below the mean and one standard deviation above the mean, we have 68% of all data values. And two standard deviations from the mean, we have 95%. And three standard deviations from the mean, we have almost all the data. Let me show you using Mindtap. So this is our Mindtap book. Let me show you everything here. So this is the Mindtap, okay, chapter 3, chapter 6, and so on. So one nice thing about Mindtap, I'm going to use chapter 6 because it has the applet I want to show you. In chapter 6, we have Chapter 6, Exploring Statistics. So let's take a look at the deviation areas of the normal distribution. So the normal distribution is very important, and we're going to talk about normal distribution during the entire semester. So this is a normal distribution. I'm going to reduce the size of this page so you can see the entire figure. So you see here, and this is the mean, the Greek letter mu, and this Greek letter sigma is one standard deviation. So in this area, you can see above and below the mean, above and below the mean, this whole shaded area, we have almost 69% or 68.3% of all area is within plus and minus one standard deviation of the mean, okay? So this is the empirical rule. So here I'm using Greek letters, but this could be a value like the 5.7 height of people, could be the amount of beverage people drink during a day, could be the grade of students, could be the amount of scores in an NFL game, could be anything. So here we can replace the mean for any number, and if the distribution of values of this variable has this bell-shaped distribution, we can apply this empirical rule. We can say that if I compute the mean and the standard deviations and I add and subtract from the mean, I have 68.3% of all values. And if I add and subtract two standard deviations of the mean, I have 95.4% of all values in the distribution. If I add and subtract three standard deviations, I have 99.7% of all distribution. If I add and subtract 4 standard deviations, I have almost everything in the distribution is within this range of values. So this becomes range of value. Okay, so this is what the empirical rule is talking about. Okay. But the empirical rule only applies when you have a bell-shaped distribution. This one doesn't have a perfect bell-shaped distribution. In this case, you cannot apply the empirical rule for executive salaries variable because it doesn't have a bell-shaped distribution. Okay, so if the variable does not have a distribution of values similar to a bell-shaped normal distribution, you cannot use the empirical rule. Okay, so this is the usage of empirical rule. If you know if the distribution has a bell shape, you know that adding and subtracting different amounts of standard deviations, you're going to include such amount, such percentage of all data values.